You step out of a spacecraft expecting alien ground beneath your feet. Instead, the sky is glowing. Not from sunlight, but from metal burning in the air. Something streaks past you sideways. It isn't rain, it's molten iron moving faster than sound. Before your brain can even process what's happening, your suit temperature spikes. The air itself is hotter than a blast furnace. The ground isn't solid, the wind isn't air, and survival isn't measured in minutes, it's measured in seconds. Because across the universe, there are worlds where the laws that keep you alive on Earth don't apply anymore. Planets where rain slices like bullets, where oceans are lava, where darkness absorbs light itself, where entire worlds are being torn apart by their own stars. These places aren't science fiction. Astronomers have already found them. And if you ever somehow stood on one of these alien worlds, you wouldn't last 10 seconds. If exploring impossible worlds and cosmic nightmares fascinates you, subscribe now, because each planet we're about to visit is worse than the last. In this video, we're counting down 7 real planets discovered beyond our solar system, each one more hostile than the one before it. Not just strange, not just extreme, but completely incompatible with human survival. Let's start with a planet where weather itself becomes lethal. Segment 1. WASP-76b. On Earth, rain is harmless. At worst, it soaks you. At best, it gives life to everything around you. So if you landed on WASP-76b, you might assume rain would still just be rain. But here, rain is molten iron. This planet is so close to its star that temperatures soar high enough to vaporize metals. Iron doesn't stay solid. It turns into gas, mixing into the upper atmosphere like steam on Earth. Then powerful winds drag that metal vapor toward the cooler side of the planet. There, it condenses back into liquid metal and falls. Not gently downward, sideways. Winds moving thousands of miles per hour whip molten droplets across the sky like horizontal shrapnel. You wouldn't just be burned by heat, you'd be blasted by metal moving faster than bullets. The mechanism is brutally simple. Extreme heat breaks metals into vapor. Temperature differences drive violent atmospheric circulation. Cooling forces the vapor back into liquid form, a weather cycle. But instead of water, it's iron. You wouldn't have time to react. Your environment would overwhelm you before your brain could even register what's happening. And yet, this still isn't the fastest or most destructive atmosphere on our list, because the next planet doesn't just throw metal at you, it turns the air itself into glass. Segment 2, HD 189733b. Wind feels invisible on Earth. You see what it moves, not the wind itself. But on HD 189733b, the wind is the weapon. From space, this planet looks calm, a deep blue sphere that almost resembles Earth. But that color is deceptive. Its atmosphere is packed with silicate particles, the same materials that form glass. Under extreme heat, those particles crystallize into microscopic shards suspended in the air. Now imagine winds screaming across the planet at thousands of miles per hour. Instead of blowing dust, the atmosphere fires glass sideways faster than sound. Every direction becomes a storm of cutting fragments, not drifting, not floating, accelerating. You wouldn't feel wind pressure first, you'd feel impact. Millions of impacts shredding anything exposed. Even protective materials would erode quickly under constant supersonic abrasion. This happens because intense heat keeps particles airborne while massive pressure differences drive unstoppable winds. There's no calm weather system, no stable climate. Just permanent storm conditions. At least on this world, you could still see something coming. The next planet removes even the idea of solid ground, because the surface itself is liquid rock. Segment 3, Corot 7b. We instinctively think of planets as places you can stand. Even hostile ones still have ground. Corot 7b breaks that expectation immediately. This world orbits so close to its star that one side never faces away. There's no night, no cooling period, just constant energy pouring into the surface until rock can't stay solid anymore. Entire continents melt into oceans of lava stretching across the horizon. Not pools, not lakes, oceans. If you somehow arrived there, your first assumption might be finding stable ground, but there isn't any. The surface shifts slowly like a glowing sea. Even the atmosphere contains vaporized rock that can condense and fall again as molten droplets. The mechanism is tidal locking combined with extreme proximity to its star. Continuous heating overwhelms the melting point of rock, keeping the surface permanently molten. You wouldn't sink slowly like stepping into mud. The temperatures would overwhelm you long before contact mattered. Survival wouldn't even begin. But heat isn't always the worst threat in the universe. Sometimes pressure is more dangerous, because pressure doesn't burn you, it crushes you instantly. Segment 4. Gliese 436b. We usually think of ice as safety, cold, stable, something that slows things down. But on Gliese 436b, ice exists in conditions that would destroy anything familiar to life. This planet is often described as having burning ice. That sounds impossible, but it comes from pressure, not temperature. The planet's gravity compresses its atmosphere so intensely that water molecules are forced into solid structures even while temperatures climb hundreds of degrees higher than boiling water on Earth. So instead of melting, the ice stays locked in place. Not because it's cold, but because it's crushed into solidity. If you arrived here, heat would already be a problem, but pressure would be worse. The atmosphere presses with enormous force, squeezing everything beneath it. Human bodies aren't designed to resist that kind of compression. Structures collapse, materials deform, biology fails instantly. The mechanism is simple physics. Pressure changes how matter behaves. Under extreme compression, substances hold forms they normally couldn't. Water becomes solid where it should vaporize. Air becomes dense enough to crush. You wouldn't freeze here. You wouldn't burn first either. You'd be compressed beyond survival almost immediately. And yet, pressure alone isn't the most destructive force in the universe, because sometimes gravity itself tears entire planets apart. Segment 5. WASP-12b. Planets feel permanent, massive, stable, but WASP-12b shows how fragile worlds can actually be. This planet orbits so close to its star that gravity is literally pulling it apart. Instead of staying spherical, the planet stretches into an oval shape, like something being pulled into a cosmic tide. Gas from the planet's atmosphere is actively being stripped away and dragged toward the star, forming a glowing trail behind it. The world isn't just hostile, it's disappearing. If you somehow hovered near it, gravity wouldn't feel consistent. The forces pulling toward the planet and toward the star would fight against each other. Tidal forces stretch everything unevenly. That includes anything you bring with you. The mechanism is tidal interaction. When gravitational forces vary across short distances, they stretch objects. On Earth, tides move oceans. Here, tides deform entire planets. You wouldn't just feel pulled downward, you'd feel pulled in different directions at once, a force biology cannot tolerate. And as terrifying as that is, at least you'd still be able to see something around you. The next planet removes even that comfort because it absorbs almost all light that reaches it. Segment 6. TRES 2b. We rely on light more than we realize. Even in darkness, there's usually reflection, moonlight, starlight, something, but TRES 2b is one of the darkest planets ever discovered. It reflects almost no light, less than charcoal, less than black paint. It absorbs nearly everything that hits it. From space, it would look like a hole cut out of reality. If you approached it, orientation becomes difficult immediately. There's no visual reference, no horizon glow, no reflected light from clouds or ground, just darkness swallowing everything. The reason is atmospheric chemistry. Light that enters gets trapped by compounds that absorb rather than scatter photons. Instead of bouncing back, energy stays inside the atmosphere as heat. So despite being dark, it's still extremely hot. You wouldn't just struggle to see, you'd struggle to understand direction, distance, movement. Human perception depends on visual feedback. Without it, even simple motion becomes disorienting. But darkness isn't the final threat, because the last planet on this list doesn't just remove light or crush matter. It turns atoms themselves unstable under extreme heat. Segment 7. Kelt 9b. We assume planets are cooler than stars. That's what makes them planets. But Kelt 9b breaks even that basic rule. This world orbits so close to its star that temperatures climb beyond what many stars experience on their surfaces. Heat here isn't just intense, it changes how matter behaves entirely. Molecules can't stay together. Even metals don't remain solid or liquid. They vaporize into glowing gas, drifting through an atmosphere hotter than molten lava. Iron and titanium don't form ground. They form clouds. If you somehow entered this environment, survival wouldn't even begin. Chemical bonds inside materials and inside your body would start breaking apart. Heat at this scale doesn't just burn surfaces, it destabilizes structure itself. The mechanism is extreme stellar radiation. The planet is tidally locked and constantly blasted with energy far beyond what Earth receives. That energy excites atoms so violently that stable forms of matter can't hold together normally. You wouldn't melt, you'd disassemble. And that's the final escalation. Not wind, not pressure, not gravity. Energy itself becomes lethal. Looking across these worlds, a pattern appears. None of them are evil. None of them are trying to destroy anything. They're simply following physics. Heat moving from hot to cold. Gravity pulling mass together. Pressure compressing matter. Radiation transferring energy. But when those forces scale beyond what life evolved to handle, survival disappears instantly. Earth feels normal because we evolved inside its narrow comfort zone. Liquid water stays liquid. Atmosphere stays breathable. Gravity stays tolerable. Temperature stays survivable. That combination is incredibly rare. These planets remind us that most of the universe isn't built for life at all. It's built for extremes. And somewhere out there, there may be worlds even stranger than these. Places where physics produces environments we haven't even imagined yet. If you want to keep exploring impossible places like this, subscribe and stay curious, because the universe always has something more extreme waiting. And the real question isn't whether humans could survive on those worlds, it's how many of them exist that we haven't discovered yet.